So now, having studied vectors previously, I want you to know that we could solve those using something different called the law of sines and the law of cosines. On top of vectors, there's all kinds of applications of the law of sines and law of cosines. But let's just talk about a ship that was traveling in an easterly direction, and the wind currents were coming out of the southwest, pushing it this way. And the resultant of this was from the tail of the first to the head of the last. Well, let's say the ship was traveling at, I'm making this number up, so 5 knots, and the water was at 1 knot. I can now solve what's called an oblique triangle, one that does not have a right angle in it, using the law of sines and the law of cosines, because I know the magnitude of the current and the speed of the ship, and I know the direction that the water is coming out of. It's coming out of the southwest, so I can describe this angle. I'm going to develop the law of sines now to solve a problem like this without using vectors. So what I'm going to do is I'm going to prove the law of sines for you using a triangle that does not, in the blue, that does not have a right angle in it, but I'm dropping the altitude, the height, the perpendicular distance from angle B to the opposite side, side B, and I would like to prove the law of sines. And I'm going to do that by using the definition of sine of a right triangle. So I'm going to start with angle A. The sine of angle A is equal to the side opposite over the hypotenuse. Please, that definition is for a right triangle that we have right here. Bit poor drawing of that, that line, but anyway, this right triangle. I'm going to come over here now and talk about angle C, and the sine of angle C is the side opposite over the hypotenuse. So the sine of angle C is the side opposite over its hypotenuse. Remember, two right triangles make up this big blue triangle, but each of these share a letter in common. It's the letter H. It's called the altitude. I'm going to get that letter H alone in each case. Here I'm going to multiply both sides by side C, and here I'm going to multiply both sides by side A. And as a result, right here I have C times the sine of angle A is equal to H. C times the sine of angle A is equal to H. And here I have A times the sine of angle C is equal to H. Well, hey, lo and behold, both of these equal H. That means that this side must equal this side since they both are set equal to H. So I can now say that C times the sine of angle A would equal A times the sine of angle C. And to get this portion of the law of sines, just these two pieces, because it's an equation with one equal sign, what I'm going to do is I'm going to divide both sides by the sine of angle C. Both sides, doing the same thing to both sides. Then I'm going to divide both sides by the sine of angle A. And as a result, this cancels out on the left side. This cancels out on the right side. And I have a statement here that says A over the sine of A will always be equal to side C over the sine of C. It works for a right triangle, but now it's good for any triangle because angle A was not a right angle, angle C was not a right angle, so I'm no longer talking about angle C as a right angle in that right triangle. So let's go ahead and solve a problem. And what I'm going to have you do is I'm going to have you fill in this box. I don't even bother with drawing pictures initially. So there's 6 pieces of information in any triangle. So in this triangle, side B is 3.07, angle A is 26 degrees, and angle C is 120 degrees. If I wanted to try to draw it, I might do something like this. I would probably put angle A right here as 26 degrees, and now I got to draw kind of a big angle for angle C at 120 degrees. I'm just trying to get a scale drawing. So this will be called side C, this would be called side A, this would be angle B, and this would be side B. Again, trying to draw something that's somewhat to scale. But in law of sines, there's always one easy first step. In this case, you're given 2 angles, and one side. So see these two angles right here? Remember that the sum of the angles in a triangle is 180 degrees. So you could find angle B here by taking 180 degrees and subtracting the 26 and subtracting the 120, which is a total of 146 that you're going to subtract. And 180 minus that 146, I believe, is 34 degrees. So your easy first step, and I'm just going to put this in red because this is something I calculated. I also like to sometimes put a little check mark by things I was given so that I can see what I'm looking to find. Now, I now need to go for side A or side C. And this is going to be hard. Normally in class I will use my arm to cover up something. So what I'm attempting to do right now is to use my arm to cover up this row and have you see that you have, out of capital A, capital B, and little b, you have 3 pieces of information out of 4. I'm going to undo covering up that row. So I could use the formula that says A over the sine of A equals B over the sine of B in order to solve for side A, what I don't know. So I'm going to put in for angle A a 26-degree angle right here. I'm putting in that 26 degrees. Side B is 3.07 over the sine of angle B, which is 34 degrees. And then now I just got to do the algebra. I just got to set these cross products equal to one another. So this cross product is A times the sine of 34 degrees. And here, this cross product is 3.07 times the sine of 26 degrees. And then to get A alone, this is A times the sine of 34. So I'm going to divide both sides by the sine of 34 degrees, and I will have found my value for side A. So I'm going to see if I can get my calculator up here. Let's see. And I'm going to move it here and see if I took 3.07 times the sine of 26 degrees and hit enter and then divided by the sine of 34 degrees, I would find the value for side A of 2.41. Let's go with 2.41. So A is 2.41. Let's put this right here. Do you see that value for A? It needs to be smaller than the value for B, because angle A is smaller than angle B. If you look at our picture up here, look at how side A looks to be smaller than side B. Again, it's because angle A is the smallest angle. Now don't dare think about using the Pythagorean theorem. Now I've got to find side C. So I'm going to cover up one of these rows because the law of sines says to use A's and B's or A's and C's or B's and C's. So pretend my arm is covering up this row that you can't see it. So I'm going to use this information right here. So B over the sine of B equals C over the sine of C is the form of the law of sines that I'm going to use. I'm going to uncover that. So again, I'm going to use side B over the sine of angle B equals side C over the sine of angle C. I'm going to go back a page for just a minute. You know, this law of sines, I only use 2 portions at a time. So right now I think I'm using this one and this one together at once. So again, B over the sine B equals C over the sine of C. So I plug in B is 3.07 divided by the sine of angle B, which is 34 degrees, equals side C over the sine of 120 degrees. And if I set these cross products equal, and I'm going to show you a trick from now on. So if I have 3.07 times the sine of 120 degrees equals C times the sine of 34 degrees, and to get C alone, I'm going to divide both sides by the sine of 34. So would you look at, in each of these cases, what I'm actually doing is I'm taking the product of the 2 things that I know that are in opposite corners, right here. So I took those and multiplied them together. And then I'm going to divide by what's opposite my unknown. So then I divided by this sine of 34 degrees in order to get C alone. It was true over here as well. I took this times this right here, right there, and then I divided by the sine of 34, which was opposite my unknown. So from now on, I'm not going to write all this algebra. I'm just going to go ahead and take this times this. Let's go ahead and show it up here. So I'm going to take, I have to move this right here, I think. So 3.07 times the sine of 120 and hit enter, and then divide that by the sine of 34 and hit enter again, and I'll get my solution for A. I'm going to call that 4.75. I'm sorry, this is C, is 4.75. Look, side C should be bigger than the others because angle C is the biggest angle. And finally, I would like you to know that if you have solved a triangle and you know that the formula for law of sines is A over the sine of A equals B over the sine of B equals C over the sine of C, then you could take your answers on your calculator and you could calculate what side A, 2.41, divided by the sine of angle A, 26 degrees, you could calculate what that is and see if that's equal to side B, 3.07, divided by the sine of angle B, and see if that's equal to side C, divided by the sine of angle C. And if these are all relatively close, then you know you did this problem accurately because the law of sine works and applies. This has gotten to be a little bit long. I'm going to come back and do the next question in our next segment.